All right, friends, welcome back. This is Mr. T, and in this video, I'm going to go ahead and talk about how to simplify rational expressions. Okay, so this is part 2 of your little series of mini videos today. I just wanted to break it up so that we didn't have one huge video here. So let's talk about how to simplify rational expressions here. So there's a very simple 3-step process. First of all, what is a rational expression? Well, basically, a rational expression is something that looks like a polynomial on top over a polynomial on bottom. So it's basically a fraction of polynomials, okay? And so since we talked about how to factor polynomials in a lesson or two ago, that's why we're introducing rational expressions here now, okay? So the first step whenever you're simplifying a rational expression is you want to factor the numerators and denominators completely. So that's using those strategies that we talked about in a couple of your previous lessons where we factored polynomials. But after that, instead of skipping straight to the canceling step, what I would like you to do is go ahead and take a look at your expression and think about any sort of domain restrictions you have, okay? You want to do that before canceling because you may cancel some things out that would contribute to a domain restriction, okay? And so let's go ahead and take a look at that here in a couple of examples. So here in example number 2, part A, it says simplify the expression. And here we just simply have a monomial over a monomial, okay? So let's go ahead and do our domain restriction first, because when you have a monomial, there's really no set strategy that you have for factoring that, right? So let's go ahead and take a look at our denominator here, which is a 10x. And the first thing we need to do to find our domain restriction is say, because that is a denominator, that is something that is not allowed to be equal to 0, okay? And so what we're going to go ahead and do here is we are going to divide both sides by 10, just like we would normally solve a regular equation. And we would get simply here, x is not allowed to be equal to 0. And that is our only domain restriction in this entire expression, okay? So, again, you want to do that before you start canceling, because when we do start canceling or reducing here, we're going to miss out on a couple of x terms that show up in the denominator. So always do that first. All right, and next we'll go ahead and skip straight to the canceling step or the reducing step. Here I just have a monomial over a monomial, so I might just take a look at these coefficients of 15 and 10, and remember that these are both something that have a factor of 5 in common. So if I take 15 divided by 5, I get 3. If I take 10 divided by 5, I get 2. And then you look at those x's, right? So if we look at these x's real quick, we have x squared over x. Remember that if you divide like bases of x, you subtract those exponents. So that would be a 2 minus 1, or in other words, just 1. Okay, so x to the first. And that'll be something that we go ahead and leave on top, right? So we'll say 3x over 2, and that will be the simplified version of this rational expression, okay? And again, this is exactly why you want to do that domain restriction part before you start canceling, because if you look at your denominator now, it's just the number 2, not really something that we can plug an x into, okay? So always do that before canceling. If you look at this next example, we have a binomial over a binomial. So this is an example of a rational expression. And again, the very first step is we want to factor everything. Okay, so let's go ahead and do that. On the top, I think we could factor out a GCF. That would just be a copy of 2, and that leaves behind x minus 2. On the denominator, that is a difference of 2 squares. It's something that looks like u squared minus v squared. And I'm not going to get too bogged down with how to factor that. You can go ahead and check a previous video if you want to brush up on how to factor these types of polynomials there, but I'll just go ahead and give away the factorization. We have x plus 2 times x minus 2, okay? Now, it's at this point that before we start canceling anything, we do want to look at those domain restrictions, okay? We want to do that now before we start canceling some things out and things start disappearing from our denominator. So our denominator at this time looks like this. That's the factored version of our denominator. So that's x plus 2 times x minus 2. So I'll write an extra copy of that down here. What we want to say is because that is in the denominator, that is an expression that is not allowed to be equal to 0, because that would mean that we're dividing by that expression, or in other words, we're dividing by 0, and we don't want to do that, okay? So the way that we kind of work out what x would have to be here if we were to solve the rest of this equation is by signifying that I'm multiplying 2 numbers here. Because of those x's, I don't know the value of either number, but I know that they are going to multiply out to be 0, so that means that one of these individually is going to be equal to 0. Okay, that's something called the zero product property. And so I'm going to set these both individually equal to 0, and I'm going to solve, all right? Actually, since I have the not equal to 0 here, I should set these not equal to 0, saying that they are not allowed to be 0, okay? And I would just solve these like regular equations. So subtract 2 from both sides of that first one. I get x is equal to negative 2. And then add 2 to both sides of the second one. You get x is not allowed to be positive 2, okay? So those represent some restrictions on the domain here, meaning that I could go back to my original expression and plug in anything I want to plug in that I want. I just can't plug in negative 2 or positive 2, Okay, and again, you want to do that before you do this canceling step, because now we are going to proceed to the canceling step where we see we've got a common factor of x minus 2 in the numerator and the denominator. If we were to cancel that out, then we would just simply have x plus 2 in the denominator, and if you just do the domain restrictions on that, you're going to be missing out on the positive 2 that we need to leave out. And that just leaves a factor of 2 in the numerator, so that is going to be our simplified rational expression. They do get a little bit more involved. So like here in part C, we have a trinomial over a trinomial. And again, I'm not going to review too much on how to factor these polynomials because that's something that we've already talked about in a previous video. So I'm just going to go ahead and skip straight to the factorization steps. On the top one, I've got x and x. I'm looking for two numbers that multiply out to make positive 12, but add to make negative 7. I think we can do that by doing negative 3 and negative 4. And then on the bottom, I've got x and x. And then I'm looking for two numbers that multiply to make negative 18, but add to make positive 3. I think we can get that by doing a negative 3 and a positive 6, okay? And so, again, at this time, before we start canceling, we do want to take a look at our denominators, and we want to figure out what our domain restriction is going to be. So I might do that over here. Another copy of my denominator, that's the factor of x minus 3 times the factor of x plus 6, and I want to say that that's not equal to 0. And so remember, use zero product property to go ahead and figure out what values are going to create some problems here for us. So I'm going to set these individually equal to 0. So x minus 3 cannot be equal to 0, and x plus 6 cannot be equal to 0. And then you would just solve these. X is not allowed to be positive 3. X is not allowed to be negative 6. Those are my two domain restrictions in this example, okay? And again, doing that before the cancellation step, because then when we cancel, we see that we have a common factor of x minus 3 in the numerator and denominator, and so our simplified rational expression is just going to be x minus 4 all over x plus 6. Last example I want to do here in this video is this last one here, part D. These are going to be some polynomials that will factor according to some of those special factoring formulas from a few videos ago. So namely on the top, this is a sum of two cubes, something that looks like u cubed plus v cubed. On the bottom, this is something that looks like u squared minus v squared, okay? So again, I'm not going to get too bogged down in this video about how these factorizations work because you could watch a previous video for that. So I'm just going to skip straight to the factorization and then we'll talk about the rest here. So the polynomial on the top in the numerator is going to factor into x plus 3 times x squared minus 3x plus 9. In the denominator, that is a difference of two squares, so that's going to factor into x plus 3 times x minus 3. Okay? And again, before we start canceling and doing the next step, we need to go ahead and take a look at our denominator and decide what our domain restrictions are going to be. So I'm going to go ahead and write another copy of my denominator down here. And I'm going to say that it is not allowed to be equal to 0 because it's a denominator. And of course, remember the idea here is that you're setting each one of these equal to 0 and solving individually. So x cannot be equal to negative 3 and x cannot be equal to positive 3. Okay, those represent our two domain restrictions here in this example. Okay, but now that we've done the domain restrictions, now we have the green light to go ahead and proceed to our canceling step. And here we have a copy of x plus 3 that there is in the numerator and denominator in common. And so that leaves behind x squared minus 3x plus 9 all over x minus 3. Okay? So, again, following that process, you want to factor everything according to the methods that we discussed in the previous videos. And then after that, you're going to look for your domain restriction. That's something that we discussed in the previous mini video for today. And then once you have done your domain restrictions, you're going to proceed straight to your cancellation steps and write those simplified rational expressions. So I hope this video has been of some help to you. If you have questions, let me know. That's all I have for this one. Thank you very much for your attention, and I'll speak to you in the next one.